All right.
He's my favorite. This is the worst.
Okay.
There's so many options.
Let's derail. Let's abort this.
Bradley, would you rather?
No, we're done. Okay. Here we go. Here we go. Here we go.
Distance. Don't just say the answer. I think it was. Oh wait, yeah, that's okay.
Okay.
I don't think this one's that bad.
Is everybody okay with B?
Yes.
Okay.
Why?
These two. Stop. Stop. Stop.
No more mentioning eating around me. I'm eating
Okay.
now.
The Y components cancel each other out.
Yeah.
Okay.
What's the equation again? I know it off the top of my head. It's gonna be.
So instead of K, it's 4 pi epsilon naught, or 1 over 4 pi epsilon naught Q over R squared.
It's D.
Capital.
Two. No, it's not.
A lot of times they'll use capital Q as the source charge, but not all the time. Okay, correct answer is? Yes, C, because we're squaring the square root for distance equation, like Pythagorean theorem. You good with that? Okay. That's R. Okay.
That definitely goes on the list of stupid things Isaac has said.
Literally did not like D.
Shh, stop, focus.
It's only Wednesday, guys. It's gonna get worse from here.
So I'll give you this hint. Consider the ratio of sides in conjunction with trig functions. Tell your neighbor.
Not ready yet. Okay. I'm going.
It's a theory. I couldn't tell you what one.
Because of X.
Yeah.
Alright. Solely because those are the only two things. Adjacent side and.
Wait, no, but then
Those are the only two you still want to
yeah,
But you don't need these.
I'll say E because that one looks slightly better.
I don't care about real data. That wraps out of my face. The total distance squared is x squared plus b squared. The x component of that distance is x. So you just multiply.
Oh. That's cool.
Yeah.
I'm in physics today, basically.
I'll give you a data, Brad.
Okay. These have the same angles. You want the cosine. They're congruent angles. So you want the cosine because you want the x component. You want the adjacent. Okay. And so
That makes sense.
so cosine is adjacent over hypotenuse.
Yeah.
hypotenuse being that.
C is next to D, so I was close.
You were. Still get the same points off.
That was kind of
Okay. Everybody go to D. Dangerous dinosaurs. Okay. So if we were to find the net electric field at this location, we got the X component from the top plus the electric field from the middle plus the X component from the bottom charge. Top and bottom, because they're equal distance from here and equal charge, you just multiply this by 2. Okay. Here, this is doing this, combine this. Okay. Where you get, this is to the 1/2 power. This is, we'll say, 2/2 power. Okay. So this is where you get 3/2. This is like 3/2 power right here.
Wait, but wouldn't you be adding another 2 added to it? Why wouldn't you add
There's twice the charge. Is that what you're asking about?
No, because I'm having trouble with the 3/2
Mm-hmm.
because it feels like there should be like the square root x squared plus d squared from the top one and from the bottom one.
It is. That's what that 2 up top is doing.
Okay.
Yeah, they don't multiply together.
Wait,
They just.
Why we do that?
Yeah, why do you cube it? Just like this.
Oh,
So we have 1/2, and we're like the power of 1/2, and to the power of 2/2. We're gonna add those 2 exponents,
Oh, so that is to the 3/2. Okay.
so you get 3/2. Everybody good with that?
Yeah.
Okay. And then you simplify that, or factor out a q
Over.
and 4 pi epsilon naught. Good with that? Okay. So here's the expression we just came up with. Yep, so this means a whole lot greater.
We'll just pretend D is 0.
And
No. We're gonna hold one constant.
Okay, when you get to here, I would recommend, rather than making x infinity, I'd make d 0.
Otherwise, 2 over x squared goes to 0.
Yeah.
Or you could do x goes to 0, d goes to 0, d goes to
No,
0. No, but d goes to 0 faster. So.
Okay, correct answer is
I did actually calculate this one.
b and c are not simplified.
C,
Oh yeah, no.
because it's like a point charge of,
I was trying
Plus
to
4.
evaluate that.
you can. So this is 0. So this becomes
2x over x cubed.
oh, and then you got that takes care of that. Okay. You got an x up top, x down below. So you got 3 halves.
No, but you can no.
Squared and then square root. So
Yeah,
x
square,
cubed and then another one.
Yeah.
Oh yeah, thank you.
And then there's an there's an x up top, so we can make it 2 over x squared instead of 2x over x cubed.
Yep. So that goes squared. That's cancels that. So you get x squareds. And add those up, you get 4.
And then we cancel out the 4s because 4
Okay.
was 1.
Just as if this was a point charge, positive 4q. Good? So I'm not going to get at this because that would not work very well. But as x approaches 0.
Oh, that's a good question.
I have to do a limit for this one actually. Oh, wow.
Correct answer is B. B. The electric fields from these two cancel out. It's close to vertical. And all you have is the electric field from this guy.
Okay, I was trying to. Oh, okay, so x doesn't actually. Okay, so we
Right.
don't actually need to take the limit because.
Right, we don't actually reach 0. Right. Things go. Right. Okay. So what we did, this is a really weird diagram. We've got 2 charged balls, and we're going to take this second one and we're going to like stretch it out. So this has the same charge as this. Tell your neighbor.
You have larger amounts.
And also they're at a further distance.
Yeah. That's true.
Do the vertical components
Yes.
Okay. So
Both.
that also still matters.
Both. Correct answer is B. Bountiful buffaloes. Okay. I do. All right. So that sets us up for, let's say we have a rod of uniform charge density.
Oh no.
So there's a lot of similarities with, remember how we talked about if you had a rod with uniform mass. Okay, uniform density. Uniform charge density will have the same thought patterns and processes, except we're using charge instead of mass.
Like it's charge density, not mass density.
Okay, so we're going to use the same variables that we did for linear density. This is linear charge density. Okay, so instead of mass over volume, it's just one dimension. So we're going to, instead of volume, it's length. And we're looking at defined as the charge per length. Okay, so this is true if it's uniformly dense, then a small chunk of this, has the same linear charge density. And if we make that really small, you can do this. A little differential.
Yeah, I was right. This was an internal setup.
Okay. Here we go. Hey. Have a conversation.
8 divided by the parameter, which is 4.
There-
I'm assuming that
That's a
Everybody good with C? You have a total charge of 8 divided by the length, which is the perimeter. Okay, so this is times 10 to the negative 9th divided by times 10 to the negative 2. Okay, do that. All right.
just thinking it's a good day because Emma hasn't done this gesture, which usually does when I'm looking at
No.
You have a question for me?
With you.
Oh my gosh.
No, stop. You can ask him later.
No.
No, we're good.
Can you stop
You-
talking so I can actually read the question?
Talk to me later.
it's a worthwhile question. It'll change your life.
What's that?
It's a worthwhile question. It'll change your life. Okay, everybody good with A? Talk to your neighbor. Everybody good with B? We're taking this ratio that we just established, and you have dq over dx. Multiply that over. Okay. All right.
Oh yeah, it was hard.
Some of us are actually bad at Spanish.
No, do you see that homework was hard? We don't turn it in.
I'm taking you in baby steps. Don't overcomplicate it.
What's that whole first constant thing? Could be electrostatically.
Yeah.
Tell your neighbor.
C.
Okay. There we go. C. You have a point charge, and you have a distance r away from that. Okay. K is the 1 over 4 pi epsilon naught. There we go. That.
Yeah.
Tell your neighbor. Correct answer is B. Okay, just because of this. dq. This is lambda times dx. Do that. Okay, just let that percolate.
Yeah, I don't use coffee.
Marinate. Okay.
Oh, I don't like
Weird seeing the multiplications.
I know it's not a cross product.
Strange. I was like
I know.
so used to that.
Use parentheses to show multiplication.
that would be also just a white.
Okay, correct answer is A. Okay, you want cosine of this angle? Just cosine of that?
Same problem as before, just rotate it.
Correct. Okay, so adjacent over hypotenuse. Do that.
Oh, we're bored. Because I think that it's funny.
Oh heck.
Oh, heck.
No. Different. Yeah. Well, one of them's different, so it'll be that one.
Yeah. Oh, it's the same question. It's just he took out all the nice variables. Not nice variables.
Mm-hmm.
They just got rid of R basically.
Yeah. The nice variable.
Which is like the thing we did last. It's gotta be that one.
Mm-hmm.
So leave that one.
There's definitely that one. I'm not gonna spoil it.
Talk to your neighbor.
Okay, so
Because we did the 3 halves.
y over R, R is square root of x squared plus y squared. So y over R, so it has to be either D or E. And it's R squared in the first one, so it can't be E.
I'm gonna have to lie.
Well, I just looked at
Correct answer is
D.
D. Dangerous dinosaurs is correct. Okay, it's the same idea as what we did with all this junk. This right here, that question. Okay, and so the culminating experience. Okay, so we combine that together to give us this.
Okay, change Q over L to be lambda.
Okay. So, how do we find the electric field at point?
Oh, just set it up. Okay, that's fine.
Just setting it up.
Oh.
Tell your neighbor.
You're gonna integrate from 0 to L.
charges.
Yeah.
Times D charge.
Okay, watch this.
Oh, can't see. Wait.
Yeah.
Oh, yeah. Oh, that's true.
Didn't have to make me like that.
Okay.
Oh, yeah, sorry.
All right. There we go with that. And we'll leave that joyous exercise for tomorrow. So work on your lab.
Why can you not do D or from 0 to L? Couldn't you
Because that's-
find 0?
If it was 0 to L,
Further away, you'll have a lower value.
right. 0 to L would be this point here.
Because if the particle's like
Okay.
What did it? Why would it be over there?
If from 0,
Oh, you did?
from like if the integral for, oh, sorry.
How was it?
Good call. From, wait, no.
Damn it. Wouldn't it still be at L? What happened?
No, it would be, sorry, final minus initial. This would be at this point.
Would 0 to L be all the way over? Would 0 to L be all the way over, way on the left?
Yeah.
Why there?
Yeah.
Instead of here. Like, why isn't it like here? Like you take this L over 2 and move it here. Wouldn't that be, or sorry.
Because you have this y, you're a certain distance above that.
Yeah, but aren't we just, if we're integrating over these bounds, isn't this point is negative L over 2 and that point over there is L over 2?
Yeah.
So shouldn't 0 to L be that area?
Oh, yeah. I'd change the
Finding the equivalent of,
I'd change the origin to that
yeah,
because they're not gonna.
because then you'd be 0 to L and that's why the point's, okay, I get it.
I don't understand why the point's there.
For 0 to L, where do you think it should be?
I don't know why that would change where the point is.
Because we're saying that x is 0 here. Like if I make the origin here, then x is 0 here, and then the furthest x would be.
So why does that mean that that's there?
Okay, so I'm ignoring this.
Yeah.
I'm just doing. Okay, then it hits.
Because if x is 0, it has to be directly above x.
Yeah.
So.
Yeah. Okay. Good.
I don't keep any.